Hey, hi everyone. My name is Vinita, and proceeding in this series of practice sessions on Maths Optional, we are covering real analysis topics today. And मैंने इसमें थोड़ा सा improvisation किया है that we will not be taking random subjects. I'll be taking one subject at a time, and we'll be covering concepts of that subject. And once we are done with one subject, then we'll go to the other subject. All right. This series is going to be beneficial to you if you have studied the topic, है ना. तो रिविजन के लिए you can make the best use of this series. Also, I have started my test series as well. If you have completed your syllabus, then you can give test and you can assess yourself and you can improve yourself. इसमें जो इवेल्युएशन रहेगा वो विद फीडबैक रहेगा. सॉल्यूशंस आई बी प्रोवाइडिंग यू एंड उससे आपको एक आइडिया लगेगा दैट हाउ कैन वी प्रेजेंट इन द एग्जामिनेशन होल, है ना. यू कैन क्लियरली सी दैट दिस इज द पेपर ऑफ रियल एनालिसिस दैट आई हैव कंपाइल्ड, I have designed basically. इसमें I have covered diverse topics. I mean the topics that are asked in UPSC in last 10 to 15 years, the topics that are asked or probable topics that can be asked in upcoming examinations. तो वो सारे cover किए हुए. For instance, this is the question for uniform convergence, then improper integral, maxima, minima, continuity, uniform continuity, convergence, L'Hopital rule, then Riemann integrability. Then there are questions mean value theorem पर based हैं, then maxima, minima again, then uniform convergence. So that's how each and every test will be designed with the proper analysis and with the proper assessment of previous year questions. जो probable topics हैं those will be covered in these test series. देखो, आई नो आपको लगेगा कि ये वाले क्वेश्चंस तो हमने किए हुए, बट टेस्ट सीरीज इज बेसिकली टू असेस योर सेल्फ हाउ कैन यू अटेम्प्ट विदाउट लुकिंग एट द आंसर्स, है ना. सो कैसे आप सॉल्व करते हो. एंड in each and every test I introduce something new because UPSC has this tendency कि हर साल कुछ ना कुछ नया वो introduce करते हैं ना मैथ्स ऑप्शनल में. तो that's how each and every test will be designed. So the link of this test series is given in the description below this lecture. आप check कर सकते हो detailing about all the tests. Alright, let's continue. So today's topic of discussion is real analysis. I'll be covering three major topics here. One is the P test for convergence, ratio test for convergence, Rabi's test for convergence, है ना. तो this lecture is based on convergence of infinite series and this is from real analysis paper 2 section A. Okay, let's look at the very first question. This is the series given to us. I have to assess its convergence. The concept that is used in it is geometric progression. Geometric progression में क्या होता है. Let's suppose I have a geometric progression A plus AR square plus AR cube up to so on. So you can see that the common ratio here is R. This series converges if mod of R is less than 1 and the series diverges if mod of R is greater than equal to 1. ठीक है. Now let's look at the very first question. Just remember this. If mod R is less than 1, series converges. If mod R is greater than equal to 1, series diverges. So you expand the series, n को 1 put करेंगे. So 9 into 2 to the power 1 minus 1 divided by 5 plus 9 into 2 to the power 2 minus 1 divided by 5 square plus 9 into 2 to the power 3 minus 1 divided by 5 cube plus 9 into 2 to the power 4 minus 1 divided by 5 to the power 4 up to so on. This is equal to 9 into 1 by 5 plus 9 into 2 by 5 square plus 9 into 2 square by 5 cube plus 9 into 2 cube by 5 to the power 4. Slight adjustment is needed here, है ना. 9 by 5 plus 9 by 5 into 2 by 5 plus 9 by 5 into 2 square by 5 square. Similarly, plus 9 by 5 into 2 cube by 5 cube plus up to so on. If I take 9 by 5 out here, it is 1 plus 2 by 5 plus 2 by 5 again, 2 square by 5 square plus 2 cube by 5 cube plus up to so on. अब देखो this is my geometric progression. इसमें this is the first term, this is second term, this is third term. So you find the ratio of the second to the first term. I mean to say you find A2 by A1. है ना, let's say this is A1, this is A2, this is A3, this is A4 up to so on. So you find A2 by A1, what are you getting? It is 2 by 5. You find A3 by A2, A3 by A2. This is equal to 2 square by 5 square divided by 2 by 5. You will get 2 by 5 again. और आपको समझ भी आ रहा है 1 इंटू 2 बाई 5 इज़ 2 बाई 5, 2 बाई 5 इंटू 2 बाई 5 इज़ 2 स्क्वायर बाई 5 स्क्वायर. So here r is equal to 2 by 5. And you know that mod of r or mod of 2 by 5 is less than 1. And whenever r is less than 1, we can say that our series diverges. Converges. The series converges here. Okay? So this was the first question. Now look at the second question. Second question भी same है मेरे पास. Here also there is a series given to us जो कि geometric progression बना रही है. यहाँ पर इसको हम expand कर सकते हैं, इसको लिखा जा सकता है n going from 2 to infinite, 2 to the power n by 3 to the power n plus summation n going from 2 to infinite minus 1 to the power n by 3 to the power n. Let me raise this. Okay, so here if you expand these expression, सबसे पहले first expression को expand करोगे, you will get 2 square by 3 square plus 2 cube by 3 cube plus 2 4 by 3 to the power 4 plus 2 5 by 3 to the power 5 up to so on. And the second expression is minus 1 by 3. If I put n is equal to 2 first ना, 2 से start हो रही है series, so it will be 1 by 3 square minus 1 by 3 cube plus 1 by 3 to the power 4 minus 1 by 3 to the power 5 plus 1 by 3 to the power 6 plus up to so on, minus up to so on. In the first series, this is a geometric progression with r is equal to 2 by 3. Because इसमें 2 by 3 multiply करोगे, you will get the second term. इसमें 2 by 3 multiply करोगे, you will get the third term. Multiplying 2 by 3 to it, you will get the fourth term. This way you will keep getting the next term, है ना. So here r1 is equal to 2 by 3. And what is r2 here? In the second series, what is r? 1 by 3 square should be multiplied to what in order to get minus 1 by 3 cube. Minus 1 by 3 से multiply करने पर मिल जाएगा मुझे. Similarly, minus 1 by 3 से multiply करोगे, you will get the third term. Similarly, multiply करो इसको minus 1 by 3 से, you will get the fourth term and so on. आपको इस तरह से terms मिलते जाएंगे. So r2 here is equal to minus 1 by 3. ठीक है. So here mod of r1 is which is equal to mod of 2 by 3 and which is less than 1. Similarly, mod of r2 which is equal to mod of minus 1 by 3 which is again less than 1. So it implies the first series converges and the second series also converges and they both are added here, so the overall series is convergent. जो overall series है वो convergent है यहाँ पर. So whenever r is less than 1, the series converges, and whenever r is greater than equal to 1, the series diverges. This was the first concept. Now moving on to the next concept. Next concept is based on p-test. P-test says that summation 1 by n to the power p series converges if and only if p is greater than 1 and diverges if p is less than equal to 1. Memorize it for p greater than 1. Converges if p is greater than 1. That's it. For instance, this is the question I have, है ना. तो here p is equal to 2 by 3. P is equal to 2 by 3 and 2 by 3 is less than 1. So the given series diverges. वहीं पर if the question was, अगर question इस तरह से होता है summation n going from 1 to infinite 1 by n to the power 5. Since 5 is greater than 1, तो series convergent हो जाती. Similarly, summation n going from 1 to infinite 1 by n to the power 1 by 3 is less than 1. So series is divergent here. So whenever p is greater than 1, series is convergent. Let's do this question now. तो इसमें क्या है, I can write this question as summation n going from 1 to infinite n square by n to the power 5 by 2 minus summation n going from 1 to infinite 3 by n to the power 5 by 2, है ना. अब इसमें n क्या है, this is equal to summation n going from 1 to infinite. I can write this as 1 by n to the power 1 by 2, 5 by 2 minus 2 minus summation n going from 1 to infinite 3 by n to the power 5 by 2. Because 1 by 2 is less than 1, so this series is divergent, and because 5 by 2 is greater than 1, so this series is convergent. So out of these two, one series is divergent, other series is convergent. So overall my series will diverge. So this is a divergent series. ठीक है, तो if both are divergent, the series will diverge. If both are convergent, series will converge. Their summation and their difference, है ना. Sum of two convergent series is convergent. Sum of two divergent series is divergent. ठीक है. एंड वेन एवर देर इज डिफरेंस एज वेल, डिफरेंस में भी सेम चीज़ रहेगी. इफ वन सीरीज इज कन्वर्जेंट, अदर इज डाइवर्जेंट, ओवरऑल माई सीरीज विल डाइवर्ज. सो इट इज़ ए डाइवर्जेंट सीरीज. अंडरस्टूड. नाउ लेट्स डू द अनदर क्वेश्चन. बाकी क्वेश्चंस करते हैं. ओके. So actually based on p test na, based on p test we have a comparison test. है ना. कंपैरिजन टेस्ट क्या कहता है, यू बेसिकली कंपेयर, लेट्स सपोज समेशन यू एन कन्वर्जेंस हैज़ बीन आस्क्ड टू अस, सो वी विल कंपेयर दिस टू समेशन 1 बाई एन टू द पावर पी. We will compare this to summation 1 by n to the power p, and if limit n tends to infinite, summation un by, let's suppose I define it as summation vn. If the ratio, if I take this ratio summation un by summation vn, and if I take limit n tends to infinite, and it comes out to be finite, then my series summation un and summation vn converges and diverges together, converges plus diverges together. So p test का सबसे ज़्यादा यूज़ किया जाता है comparison test में. This is called comparison test. We are basically comparing the given series to another series जिसका convergence और divergence मुझे पता है. So we will compare this series to any 1 by n type of series, 1 by n to the power p type of series. अब आप p कैसे डिसाइड करोगे वो समझ लेते हैं. लाइक इन दिस क्वेश्चन, दिस इज माई गिवन सीरीज एज समेशन यू एन. आई हैव टू कंपेयर इट टू सम अदर सीरीज, है ना. वी विल यूज कंपेरिजन टेस्ट हियर. सो समेशन वी एन इज इक्वल टू, देखो जो न्यूमरेटर में n का हाइएस्ट पावर है ना, द हाइएस्ट पावर ऑफ न्यूमरेटर, हाइएस्ट पावर ऑफ n इन न्यूमरेटर, तो वो लिख लो n टू द पावर 1 by 2 इट इज़. Highest power of n in the denominator, it is 3, so you will write n to the power 3 here, and you will get vn here, है ना. So you basically simply take the highest power of n in the numerator and highest power of n in the denominator. अब इसको थोड़ा सा एडजस्ट कर दो. दिस इज 1 by n to the power 3 minus 1 by 2, which is 1 by n to the power 6 minus 1, that is 5 by 2. Take a summation with it, take it summation with it. Now you find limit n tends to infinite un by vn. This is equal to limit n tends to infinite n to the power 1 by 2 divided by n to the power 3 plus 1 n to the power 5 by 2. This is equal to limit n tends to infinite, and isn't it 1 by n to the power, if I take n cube out, नीचे से अगर हम n क्यूब को बाहर लेते हैं, n क्यूब आउट, 1 प्लस 1 बाई n क्यूब, 1 by n cube, n to the power 1 by 2, n to the power 5 by 2. This together will give me n cube, so this got cancelled out. Now if I take n tends to infinity, then it will be 1, the denominator will become 1, overall the answer is 1. 1 is finite plus non-zero, non-zero है, finite है, so it implies un and vn converges and diverges together. What can you say about vn? Summation 1 by n to the power 5 by 2 converge करता है या diverge करता है? Obviously it is convergent. because by p test 5 by 2 is greater than 1 and whenever p is greater than 1 my series is convergent. So summation vn converge करता है यहाँ पर, so it implies summation un converges as well, है ना. तो un भी यहाँ पर converge करेगा. नाउ कमिंग टू दिस क्वेश्चन, ये वाला जो क्वेश्चन है इसमें हमारे पास द पावर्स वी कैन नॉट, इफ वी हैव दिस टाइप ऑफ एक्सप्रेशन ना, यू हैव टू रैशनलाइज इट फर्स्ट. हमारे पास माई एक्सप्रेशन शुड बी इन दिस फॉर्मेट, मतलब एक रैशनल फंक्शन होना चाहिए, बट दिस इज़ नॉट ए रैशनल फंक्शन, सो इसको रैशनलाइज करना पड़ेगा हमें यहाँ पर, है ना. तो मैं थोड़ा सा नीचे लिख देती हूँ इसको. I'll write this question later, इसको मैं बाद में लिख दूँगी. Let's first, okay ये रेज नहीं हो रहा है. रूट एन टू द पावर 4 प्लस 1 माइनस एन स्क्वायर, जैसे ये क्वेश्चन है मेरे पास. क्वेश्चन सेज दैट अंडर रूट एन टू द पावर 4 प्लस 1 माइनस एन स्क्वायर. इफ़ दिस इज़ द क्वेश्चन आई हैव, रेशनल नहीं है, न्यूमरेटर बाई डिनोमिनेटर की फॉर्म में ये नहीं है, सो आई नीड टू रैशनलाइज इट फर्स्ट. एन टू द पावर 4 प्लस 1 प्लस एन स्क्वायर under root n to the power 4 plus 1 plus n square. From here you will be getting n to the power 4 plus 1 minus n to the power 4 divided by n square plus under root n to the power 4 plus 1. This is equal to 1 by n square plus under root n to the power 4 plus 1 and this is my summation un. This is my summation un. ठीक है, या un ले लो, un. Okay, now I need to compare it to some other series. So as I told you, vn can be written as, what is the highest power of n in numerator? 1 only, there is no n in numerator, so 1 only. What is the highest power of n in denominator? n to the power 4 under root 2, है ना. तो here it is 2 power, here it is 2 power. So I'll take vn to be 1 by n square. Now you take limit n tends to infinity un by vn and that is equal to limit n tends to infinity n square by n square plus under root n to the power 4 plus 1. So this is equal to limit n tends to infinite n square by, if I take n square out, 1 plus under root 1 plus 1 by n to the power 4. And you can clearly see that if I put n tends to infinite, तो ये क्या हो गया, 1 plus 1 by infinite 0, 1 by infinite 0 होता है, तो नीचे बच जाएगा 1 plus 1. So 1 by 1 plus 1, that is 1 by 2, which is finite plus non-zero, plus non-zero. So it means un and vn converges and diverges together. un and vn converges and diverges together. Diverges together. Now what can you say about vn? vn का हमें पता है ये converge करता है या diverge करता है. 2 is greater than 1, so it is convergent by p test, by p test, because p is greater than 1. So अगर ये converge करता है, so it implies जो हमारा series है, it is also convergent. Our series is also convergent. So this was comparison test. ठीक है, तो फर्स्ट वी अंडरस्टूड पी टेस्ट. डायरेक्टली पी टेस्ट से क्वेश्चन तो मुश्किल है आना, बट दे कैन आस्क यू पी टेस्ट बाय कंपैरिजन, है ना. सो इन कंपैरिजन टेस्ट वी हैव टू कंपेयर ए गिवन सीरीज टू 1 बाई एन टू द पावर पी टाइप ऑफ सीरीज, है ना. एंड पी इज डिसाइडेड बाई टेकिंग हाइएस्ट पावर ऑफ एन इन द न्यूमरेटर एंड हाइएस्ट पावर ऑफ एन इन द डिनोमिनेटर, है ना. तो वहाँ पर आपको पी मिल जाएगा एंड देन यू कैन सिंपली असेस द limit n tends to infinite un by vn. This is called comparing un and vn, and you will get this limit as finite plus non-zero. So we can say that un and vn converges plus diverges together. Now you can easily assess vn because vn is nothing but 1 by n to the power something, है ना. तो p test से vn का पता है हमें, so you can guess about un. Understood? All right. Let's discuss the other question. So far हमने क्या क्या कौन कौन से क्वेश्चंस कवर कर लिए. ये कवर हो गया, दिस ऑल्सो डन, दिस ऑल्सो डन. एंड देन देर वर 2 क्वेश्चंस बेस्ड ऑन ज्योमेट्रिक प्रोग्रेशन, है ना, तो पी टेस्ट पर और ये ज्योमेट्रिक प्रोग्रेशन पर बेस्ड ये 2 क्वेश्चंस. सो 1 2 3 4 5 6 क्वेश्चंस हो गए. अब ये क्वेश्चन है ना, ये बहुत ही सिंपल क्वेश्चन है. इसमें जस्ट मैं आपको एक कॉन्सेप्ट बताना चाहती हूँ कि whenever लिमिट n टेंड्स टू इनफाइनाइट un is not equal to 0, then summation un is not convergent. Remember it, not convergent, है ना. और अगर ये 0 आ जाता है तो then you cannot say anything about the convergence or divergence. But if it comes out to be non-zero, then summation un is not convergent. This can be like very first test, basic test that you can use while checking convergence for the divergence for the series. जैसे यहाँ पर है, here un is equal to the last term. What is the last term here? N to the power 1 by 2 divided by 2 to the power 1 by 2 and under root n plus 1. Now if I take limit n tends to infinite un, then this is equal to limit n tends to infinite un. This is equal to limit n tends to infinite n to the power 1 by 2 divided by 2 to the power 1 by 2. If I take n to the power 1 by 2 out from here, I'll get under root 1 plus 1 by n. This got cancelled out, and if I take n tends to infinite, तो ये तो 1 plus 0 1 हो जाएगा, and I'll have the answer 1 by under root 2 for this limit. So limit n tends to infinite un is 1 by root 2, which is not equal to 0. So you can straight away say that the given series is not convergent. If I get limit n tends to infinite un to be non-zero, then we can say this series is not convergent. ठीक है, क्योंकि सीरीज जब कन्वर्ज करती है ना तो लिमिट हैज़ टू बी ज़ीरो, लिमिट हैज़ टू बी ज़ीरो. बट लिमिट अगर ज़ीरो होती है देन यू कैन नॉट सी एनीथिंग अबाउट द कन्वर्जेंस ऑफ द सीरीज. बट इफ़ द सीरीज कन्वर्जेस then its limit has to be 0. Okay, now let's do the next question. So this was all about p-test and comparison test. अब आगे हम बढ़ते हैं. Now this question is based on रेशियो टेस्ट. सो पहले लेट मी एक्सप्लेन यू द कॉन्सेप्ट ऑफ रेशियो टेस्ट. रेशियो टेस्ट क्या कहता है? सो रेशियो टेस्ट सेज दैट लिमिट n टेंड्स टू इनफाइनाइट un plus 1 by un. Let's say the value of this limit is equal to L. Let's say the value of this limit is equal to L. Then by ratio test, the series is convergent if L is less than 1, and series is divergent if L is greater than 1, L greater than 1, and the test fails if L is equal to 1, if L is equal to 1. That's it. So you pick the nth term of the series and you find the n plus first term and you find this ratio, you take a limit एंड इस लिमिट का वैल्यू फाइंड करेंगे. सो सीरीज कन्वर्ज करेगी इफ़ यू गेट एल टू बी लेस देन 1 एंड डाइवर्जेंट इफ एल इज ग्रेटर देन 1 एंड टेस्ट विल फेल इफ एल इज इक्वल टू 1. सोल्यूशन लाइक हेयर यू हैव टू फाइंड द nth टर्म ऑफ द सीरीज, है ना. तो यहाँ पर असेस करो. व्हेन n इज इक्वल टू 1 यू कैन इग्नोर द फर्स्ट टर्म. फर्स्ट 2 टर्म्स यू कैन इग्नोर, है ना, अगर वो नहीं बैठ रहा, सूटेबल नहीं है हमारे उसके अकॉर्डिंग, है ना. तो जैसे एन को जब मैं 1 पुट कर रही हूँ तो आई एम गेटिंग एक्स टू द पावर 2 by 2. व्हेन n इज इक्वल टू 2 देन आई एम गेटिंग एक्स टू द पावर 4 by 4. एट n इज इक्वल टू 3 आई एम गेटिंग एक्स टू द पावर 6 by 6. नेक्स्ट टर्म होगी एक्स टू द पावर 8 by 8. सो एट n इज इक्वल टू 4 आई एम गेटिंग एक्स टू द पावर 8 by 8. तो आपको नहीं लगता कि द सीरीज इज गोइंग ऑन लाइक दिस कि 1 प्लस एक्स टू द पावर 2 इंटू 1 by 2 इंटू 1 प्लस एक्स टू द पावर 2 इंटू 2 by 2 इंटू 2 प्लस एक्स टू द पावर 2 इंटू 3 by 2 इंटू 3 प्लस एक्स टू द पावर 2 इंटू 4 by 2 इंटू 4. सो आई कैन राइट द nth टर्म ऑफ द सीरीज. क्या हो जाएगा? एक्स टू द पावर 2 इंटू n by 2 इंटू n. This is my nth term of the series. You can ignore the first term, कोई ऐसे issue नहीं है ना. So here un is equal to x to the power 2n by 2n. Now what is un plus 1? It is equal to x to the power 2n plus 2 divided by 2n plus 2. Now you find the limit n tends to infinite un plus 1 by un. And this is equal to limit n tends to infinite. This is x to the power 2n plus 2 divided by 2n plus 2 into 2n by x to the power 2n. You find the value of this limit. So limit n tends to infinite, I can write it as x square because x to the power 2n will get cancelled out into 2n divided by, take 2n out from here, 1 plus 2 by 2n, and this 2n got cancelled out, and when I'll be taking n tends to infinite ना, तो ये तो 0 हो जाएगा, so 0 plus 1 is 1, so answer will be just x square. So इसका मतलब जो series है summation un converges if x square is less than 1 and summation un diverges if x square is greater than 1, but the test fails if x square is equal to 1. If x square is equal to 1 because the value of the limit is dependent upon x. So आपको इसी तरह से proceed करना पड़ेगा, ठीक है. So मुझे ये result मिला, but the test fails if x square is equal to 1. So जहाँ पर test fail होता है इसका मतलब go back to your series, put x square equal to 1, then assess the series by using different test. कोई दूसरा टेस्ट यूज़ करके assess करो, है ना. तो एक्स स्क्वायर को 1 पुट करेंगे, पुट एक्स स्क्वायर इज इक्वल टू 1 इन द सीरीज इन समेशन un. तो अपने पास क्या आ जाएगा, दिस विल बी इक्वल टू 1 प्लस एक्स स्क्वायर को 1 पुट किया तो 1/2, देन 1/4, देन 1/6 प्लस अप टू सो ऑन, एंड दिस सीरीज इसकी जो nth टर्म होगी दैट विल बी 1/2n. Isn't it the series summation 1/2n? Simple it is. N going from 1 to infinite. I can write it like this. Okay, n going from 1 to infinite 1/2n. Now you tell me, is this series convergent or divergent? Because this is based on p test now, है ना. तो p test के according, as per p test, n की power यहाँ पर क्या है 1 है. And I told you that 1/n to the power p converges only if p is greater than 1. अगर p greater than 1 है तभी ये converge करती है, otherwise it diverges. So it implies this series diverges. ठीक है, तो when x square is equal to 1 then the series diverges, है ना. तो यहाँ पर आप equality लगा दो. The series diverges if x square is greater than equal to 1 and converges if x square is less than 1. So you can note it down. So moving on to the next question, this is also based on ratio test. See, the very first test is your comparison test, है ना. आपको लगता है comparison लग सकता है, then you do the comparison test. But when comparison test doesn't work, then go for ratio test. Ratio test is the basic test. So in each and every question you have to first think of the ratio test, है ना. So solution. Here un is equal to n factorial by n to the power n, है ना. Summation n going from 1 to infinite, this is un only. The nth term is given to us. Now un plus 1 is equal to n plus 1 factorial divided by n to the power n plus 1. You take limit n tends to infinite un plus 1 by un, and that's equal to limit n tends to infinite n plus 1 factorial by, हाँ यहाँ गड़बड़ कर दी मैंने, ये n plus 1 इसको भी तो चेंज करोगे ना. You will put n as n plus 1 everywhere. So n plus 1 to the power n plus 1. So n plus 1 to the power n plus 1 and un is n to the power n by n factorial, like this. This can be written as limit n tends to infinite. I can write it as n plus 1 into n factorial, है ना, and n to the power n divided by n plus 1 into n plus 1 to the power n into n factorial. n factorial से n factorial गया, n plus 1 से n plus 1 गया. This is limit n tends to infinite n by n plus 1 to the power n, n by n plus 1 to the power n. Now देखो यहाँ पर ना एक कॉन्सेप्ट होता है I can write it, just a moment. कहाँ गया? There is a concept here that, and you have to remember it. Limit n tends to infinite. Limit n tends to infinite. N plus 1 by, sorry, 1 plus 1 by n, 1 plus 1 by n to the power n is equal to e. ये एक्सपोनेंशियल के इक्वल होता है, e टू द पावर 1 के इक्वल होता है. लिमिट n टेंड्स टू इनफाइनाइट, 1 plus 1 by n to the power n is equal to e. So isn't it equal to limit n tends to infinite 1 by, I can write it as 1 plus 1 by n. You will take n common here, isn't it? Limit n tends to infinite n by, if I take n common now, common here, 1 plus 1 by n to the power n it is. N से n got cancelled out. So this is 1 by 1 plus 1 by n to the power n. And it is, isn't it 1 by e? And 1 by e क्या होता है? Is it less than 1 or greater than 1? It is less than 1. So less than 1. So it implies limit n tends to infinite un plus 1 by un is equal to 1 by e, and it is less than 1. So it implies summation un is convergent by ratio test. By ratio test. Okay, so this was the ratio test here. All good. Now the next question is based on, again you have to first apply ratio test. You have to first apply ratio test, है ना. तो nth टर्म हमें दे रखी है यहाँ पर. So un is given to us as 2 to the power n minus 2 divided by 2 to the power n plus 1 x to the power n minus 2. You find un plus 1. It is equal to 2 to the power n plus 1 minus 2 divided by 2 to the power n plus 1 plus 1 x to the power n plus 1 minus 2. This is equal to 2 to the power n into 2 minus 2 divided by 2 to the power n into 2 plus 1 into x to the power n minus 1. You find limit n tends to infinite un plus 1 by un. And that's equal to limit n tends to infinite 2 to the power n into 2 minus 2 divided by 2 to the power n into 2 plus 1, and then it is 2 to the power n plus 1 by 2 to the power n minus 2 into x to the power, just a moment, ये हो जाएगा x to the power n minus 1 by x to the power n minus 2. un is in the denominator ना, and un plus 1 is in the numerator, है ना. तो ये numerator में रहेगा and this will go in the denominator. ठीक है. So isn't it equal to limit n tends to infinite? You can take 2 to the power n out here. So ये हो जाएगा 2 minus 2 by 2 to the power n divided by 2 plus 1 by 2 to the power n. Here also I can write it as 1 plus 1 by 2 to the power n, 1 minus 2 by 2 to the power n, and it will be x to the power n minus 1 minus n minus 2, n minus 2. Okay, so isn't it limit n tends to infinite, है ना. You put the limit n tends to infinite, तो ये तो 0 हो गया, तो यहाँ पर 2 बचा, ये भी 2 बचा, यहाँ पर 1 बचेगा जस्ट, एंड x की पावर क्या बचेगी, n minus 1 minus n plus 2, n minus 1 minus n plus 2. So I'm just getting x here, है ना. तो just getting x, 2 से 2 cancel out हो गया, and x की पावर 1 आ रही है. So the value of this limit is x. So by ratio test, summation un converges if x is less than 1, and diverges, summation un diverges if x is greater than 1. Now for x is equal to 1, the test fails. Test fails at x is equal to 1. Again I told you, whenever the test fail, you go back to the original series and you put the value of x there, है ना. ओरिजिनल सीरीज में x का वैल्यू पुट करेंगे तो मेरे पास un क्या आ जाएगा, 2 to the power n minus 2 summation un is equal to summation 2 to the power n minus 2 divided by 2 to the power n plus 1 at x is equal to 1. Now which test can you use here? मैंने आपको 3 टेस्ट बताए हैं. ज्योमेट्रिक प्रोग्रेशन वो तो ये नहीं है. पी टेस्ट इसमें आई डोंट थिंक यूजफुल है, बिकॉज पी टेस्ट यूज़ करने के लिए ना जो यू एन का एक्सप्रेशन है दैट शुड बी सम पॉलिनोमियल इन एन डिवाइड बाई सम अदर पॉलिनोमियल इन एन, है ना. तो ऊपर नीचे एन की पावर्स में एक्सप्रेशन होना चाहिए इन ऑर्डर टू यूज़ कंपैरिजन टेस्ट. नाउ द थर्ड टेस्ट जो मैंने बताया कि वेन एवर द लिमिट इज़ कमिंग आउट टू बी नॉन ज़ीरो वी कैन डायरेक्टली से दैट यू एन इज़ नॉट कन्वर्जेंट. तो यहाँ पर लिमिट पुट कर दो, लिमिट एन टेंड्स टू इनफाइनाइट यू एन. So this is equal to limit n tends to infinite 1 minus 2 by 2 to the power n divided by 1 plus 1 by 2 to the power n. And the answer here is 1. 1 is not equal to 0. So it implies summation un is not convergent at x is equal to 1. है ना. तो x is equal to 1 पर सीरीज कन्वर्जेंट नहीं है. तो इसका मतलब है summation un converges if x is less than 1 and diverges if x is greater than equal to 1, because equal to 1 पर भी सीरीज डाइवर्ज करती है. एंड दिस इज माई फाइनल आंसर. ऑल राइट, टिल हियर लेट्स कंक्लूड इट हियर. रेशो टेस्ट तक हमने इसके क्वेश्चंस किए. ये वाला क्वेश्चन हम नेक्स्ट सेशन में लेंगे, नहीं तो सेशन बहुत लंबा हो जाएगा. सो फार इसमें इस लेक्चर में हमने रेशो टेस्ट के 2 क्वेश्चंस कवर किए. This question and this question was 3 questions we have covered from ratio test. So just focus on the concepts and revision, है ना. अगर आप इस लेक्चर को वैसे भी देखोगे ना विदाउट नोटिंग एनीथिंग डाउन, विदाउट राइटिंग एनीथिंग, है ना, तो भी इट विल बी यूजफुल टू यू, है ना, जस्ट टू ब्रश अप द कॉन्सेप्ट्स, है ना. ऑल राइट देन, बाय एवरीवन, टेक केयर. आई विल सी यू इन अनदर सेशन.